Hey folks, we're going to start off this unit pretty easy by discussing molar mass. Molar mass it gives us the ability to figure out uh, how large a molecule is based on its average atomic mass. And we can do this three ways, okay? Um, we can calculate just the atomic mass, which is going to be just the molar mass for just an element. Okay, we can also calculate molecular mass, which is the molar mass of a molecule or a covalent compound. And we can also calculate the molar mass of an ionic compound. That's going to be called the formula mass. Okay, so when we do this, we are going to use our periodic table. So the periodic table, as you can see, gives us all of these little bitty numbers down here, which is the molar mass. Okay, now when I scroll my mouse over these, it tells me what the molar mass is right here. Okay, so this number would be the molar mass. Remember, this is the atomic number up top here, and this number down here is the average atomic mass, which we're going to use for calculating molar mass. So let's get back to our examples here. And it wants us to find the formula mass of calcium phosphate. Now, the reason why it says the formula mass is because calcium phosphate is an ionic compound, meaning that since it's an ionic compound, it isn't a molecule, so we wouldn't call it the molecular mass. It's not an atom, so we wouldn't call it an atomic mass. We're going to call it formula mass, okay? Or I could just use the broad heading of molar mass. So let's go ahead and take a look here. Now, the first thing that I need to be able to do is I need to be able to write my formula for calcium phosphate. So my formula, I've got calcium, and I've got phosphate, which is PO43 minus. And I know that phosphate has a -3 charge and calcium has a +2 charge. So what I need to do then is I need to balance out those charges by saying that I'm going to have 3 calciums and 2 phosphates. So what I'm going to do in order to calculate the molar mass is I need to count how many atoms I have. So I have 3 calcium atoms. I have phosphorus, I've got 2. And oxygen, I've got 4 that's part of phosphate, but I've got 2 phosphates, so I've got a total of 8 oxygens. Okay, now when I go back to my periodic table, I see that calcium has a molar mass of 40.078. Okay, now what we want to do is we want to round that 40.078 to 2 decimal places. Okay, so we would say that calcium is 40.08. Phosphorus is 30.97, and oxygen is 15.999. So we're just going to call that 16.0 to be as easy as possible. Okay, so calcium was 40.08. And so 3 times 40.08 is 120.24. Phosphorus was 30.97. So that's going to give us 61 point, let's see here, 61.96, is that right? And, wait, no, 94, there we go. And oxygen was 16, 8 times 16, I believe that's 96. And lastly, we're just going to add all of these things up. Oh, wait, is that 108 actually? All right, so it is actually 128. And when we do that math, we get that the actual molar mass is 120.24 plus 61.94 plus 128. And we get that the molar mass, or the formula mass, which is the same thing, of calcium phosphate is 310, where's my mouse at? There it is, 310.18. Now, we will need units every time, okay? And our units for this is going to be AMU. Now, later, when we start to understand what a mole is, we're going to use the unit grams per mole. Okay. Now we don't know what a mole is yet, but later on we're going to use the term grams per mole. Okay. Let's do one more. Excuse me. Let's do the molecular mass of dichlorine heptaoxide. Okay, so dichlorine heptaoxide is going to be Cl2O7. So now what I'm going to do is I'm going to say, oh, okay, I've got 2 chlorines and 6 oxygens. Okay, I know that the atomic mass or the molar mass of chlorine is 35.45 and the molar mass of oxygen is 16.00. Now, where did I get those numbers? I get those from the old periodic table over here. Oxygen, 16, and chlorine, 35.45. Okay, that's where those numbers come from. So what I want to do now is I want to multiply these together. So 35.45 times 2 is 70.90. 6 times 16 is 96. And we add those two numbers up, and we get 70.90 plus 96, 166.9, 166.9 AMU, or grams per mole. Either one is fine. Okay. Now let's look at one more type of molar mass problem, and that is for a hydrate. Okay, so I've got barium chlorate hexahydrate. So Ba, and then chlorate is ClO3, and there's 2 of those because barium has a +2 charge. Hexahydrate is going to be 6H2O. And so now we're going to count out all of our atoms. Okay, barium, I've got 1. Chlorine, I've got 2. Oxygen, I've got 3 times 2 is 6, plus 6 more over here. So I've got 12 oxygens. And let's see here, barium, chlorine, oxygen. Hydrogen is last. I've also got 12 hydrogens. 6 times 2 is 12. Barium is, what is barium? 150, let's see here. 137.33 is the molar mass of barium. 137.33. Chlorine is 35.45, of course. Oxygen is 16.00. And hydrogen is 1.01. And of course, you get all of that information from the periodic table. So you come over here, there's hydrogen 1.01, barium 137.33, oxygen 16.00, and chlorine 35.45. All right, so now let's go ahead and do this math. So 1 times 137.33 is 137.33. Chlorine is going to be 70.90. 12 times 16, let's see here, 12 times 16 equals 192. Excuse me. And then this is going to be 12.12. And so now what we're going to do is we're going to add all of these numbers up to find our total molar mass. So 137.33 plus 70.90 plus 192.00 plus 12.12. And we get a molar mass of 412.35 grams per mole, or AMU. Both are accepted. Both are just fine. Now, yeah, so that is how we do molar mass problems for this class. And thank you very much.